Hi, thanks for viewing my presentation, Effective Remotely Piloted Aircraft Technology on Cruise. My name is Klubertanz. Brief overview of this presentation. We'll look at an introduction, discuss the issue of RPA technology and its effect on its aircrews, and discuss a possible plan for addressing that effect. As Trevor Pinch and Weber Beaker discuss in their article, The Social Construction of Facts and Artifacts, technology is shaped by social practices. The proposed approach for studying how social practices shape technology is called the Social Construction of Technology, or SCOT. Using the SCOT approach, social practices shape technology through a process of variation and selection. This process is analogous to a technological survival of the fittest theory. As much as social practices influence technology, technology in turn influences social practices. Thomas Hughes, in his article Technological Momentum, takes Pinch and Beaker's idea a step further by advocating a broader approach called technological momentum, which infers that social development shapes and is shaped by technology. Technology has significant power to force social changes. For instance, the Arab Spring movement was almost certainly perpetuated through the use of social media technology. During the many uprisings, individuals in numerous Middle Eastern and African countries used social media such as Twitter and Facebook to build support and awareness of the issues they were protesting for and against. Without social media, most of the information regarding these uprisings would have been filtered and spun through these countries' government-controlled official media, tainting much of what the rest of the world would read and see on television. Additionally, technology influenced the behaviors and operations of groups of individuals involved in certain disciplines or areas of interest. Specifically in the data analytics discipline, there is much concern over the applications of artificial intelligence. Most people do not understand the algorithms used to power artificial intelligence, including even some of the people who use these algorithms, fueling concerns about runaway artificial intelligence that can develop a mind of its own. Another societal concern is the use of personal data for developing predictive models and the perceived impact on personal privacy. These concerns have influenced how individuals in this discipline behave and operate within this nascent field. George Ritzer, in the article Control, Human and Non-Human Robots, describes the idea of McDonaldization as the increased control through the replacement of human with non-human technology. McDonaldization involves removing human-induced uncertainty or inefficiency from a system by substituting technology in its place. An example of the McDonaldization of society is seen in the implementation of the Integrated Maintenance Information System, or IMIS, by the United States Air Force. IMIS forces Air Force aircraft technicians to follow procedures step by step to prevent missing critical steps while performing aircraft maintenance. There are positive and negative aspects to the McDonaldization of society. In the case of the USAS implementation of IMIS, the negative aspect is that the McDonaldization creates human robots who lack the ability to think creatively or adapt to situations when faced with circumstances that are not explained by IMIS's technology system. On the other hand, a positive aspect of IMIS is that it establishes a system that ensures all work is standardized and no critical steps are missed by the aircraft maintenance technicians, which could lead to loss of aircraft or pilot life. This leads decision makers to decide on the trade-offs inherent in the McDonaldization of aircraft maintenance technical manuals and technicians. In the case of IMUS, the decision was made to reverse McDonaldization and convert technical manuals to a PDF format, while maintaining the portability of the system by loading the PDF files onto iPads. As will be discussed in this presentation, remotely piloted aircraft, or RPA, have brought about many societal issues, including the impacts on RPA aircrews, RPA targeted societies, the specific individuals targeted by RPAs, and the American public. The next section of this presentation will study the issue at hand, the effect of RPA technology on RPA crews. RPAs were initially created and used as a means of providing surveillance and intelligence. RPAs have the ability to stay airborne for as long as they have fuel available, and they are not limited by a human pilot who has crew rest restrictions, which only allow a certain amount of flying time. The first use of an RPA to conduct a strike occurred in 2001, when a Hellfire missile was test-fired from a Predator RPA against a tank in the Nevada desert. Since then, RPAs have been used extensively by the United States to conduct strikes in Iraq, Afghanistan, Pakistan, Yemen, and Somalia. There are many societal issues evident in the use of RPAs to conduct strikes. There is a lot of literature on the issue examining the impact of RPA strikes on the targeted societies. However, there is little literature examining the impact of RPA technology on RPA pilots and sensor operators. RPA aircrews in much of the literature examining RPA strikes are usually regarded as trigger-happy killers who are infatuated with the video game likeness of operating an RPA and using RPAs to conduct surveillance and airstrikes. The impact of RPA technology on the aircrews who operate them will be the main focus of this presentation. As stated, RPA technology affects many different societal groups. However, the focus of this presentation will be the aircrews who operate RPAs. There's a great amount of documentation on the fact that most RPA operators are based in locations in the United States, while the drones they are operating are based in locations around the world, with a small contingent of aircrews co-located with the RPAs who are responsible for RPA takeoff and landing operations. Because the aircrews are mostly located in the United States while conducting surveillance and strike operations overseas, there is a lot of criticism on their perceived lack of courage, both from within the United States and from foreign sources. Despite this criticism, RPA aircrews experience a large amount of burnout and can even develop post-traumatic stress disorder symptoms. As Thomas Hughes hypothesizes in his article Technological Momentum, technology is both shaped by and shapes society. This idea of society shaping technology, then that technology shaping society, is seen in the context of RPA aircrews. RPAs were originally created to nullify the dangers by putting a human operator inside an airplane, by removing that human and substituting controls and technology that could be controlled remotely. Now that RPA technology has gained momentum, it has started to shape societal groups, such as the RPA aircrews. Hughes's theory of technological momentum is evidenced by the development of RPA technology as a replacement for the societal group of human aircrews. Now that RPA technology is gaining momentum, its impact on that same societal group is becoming evident. RPA aircrews experience a large amount of burnout and can even develop PTSD symptoms. Much of the burnout experienced by RPA crews is due to overwork and understaffing. RPA crews are typically scheduled to work 12-hour shifts and work 6 days straight with only a 1-day weekend. These work schedules are likely a result of the low supply of air crews and high demand for RPA surveillance and strikes. Another reason for the high rate of crew burnout is their perceived importance in the military society. An RPA crew consists of two people: the pilot, who is a military officer, and the sensor operator, who is an enlisted military member. Military pilots are generally regarded as being the best of the best. However, RPA pilots are typically regarded as fake pilots. Due to this fact, RPA pilots are not promoted as quickly as pilots who operate manned aircraft. Additionally, many of the prestigious and selective positions in military schools and commands are given to manned aircraft pilots much more often than RPA pilots. When asked about their relative position in the military society, RPA crews commonly provide the answer, second-class citizens. The incidence of PTSD symptoms has also been studied and indicated in RPA crews. There is quite a bit of debate over the validity of diagnosing RPA crews with PTSD. Most of this debate centers around the fact that RPA crews are not personally in grave danger during the execution of their duties. Hugh Gusterson, in his book Drone: Remote Control Warfare, explains that there is a large amount of intimacy between RPA crews and their targets. RPA crews sometimes monitor specific targets, either individuals or locations, for days at a time, creating a sort of intimacy between the crews and the individuals they are monitoring. Due to this intimacy, each strike can create a vast spectrum of feelings, from elation that a certain terrorist has been targeted and killed, to profound sadness that civilians, sometimes children, were killed as a result of the strike. Hugh Gusterson posits that perhaps a rethinking of the causes of PTSD may be required in light of the effects that RPA crews exhibit. Shown here on this slide is an excerpt of survey results that were gained from a survey administered to RPA operators indicating high rates of PTSD-like symptoms. There are numerous theories about the future of RPA warfare. Typically, these theories fall into two categories. One is based on a future where RPAs continue to proliferate, with non-governmental entities such as drug cartels and terrorist organizations gaining access to RPA technology for nefarious purposes. The second category of theories typically describe a future where RPA warfare is tightly controlled and specifically limited to countries or regions where open warfare exists. It is difficult to predict which of these two versions will come to pass. Most likely it will be a combination of the two. Much like modern warfare is governed by rules, which some countries and organizations adhere to while others do not, it is fair to predict that the future of RPA technology will end up much the same, with some entities following established rules and other entities not. Either way, such a system must begin by establishing the rules and agreements for the use of RPAs in warfare. Section 3 of this presentation will focus on a proposed plan to deal with the effect of RPA technology on RPA crews. RPA operation has gained its technological momentum and shows no sign of slowing down. As such, changes must be made to mitigate the impact of RPA operations and technology on the crews that operate them. First, a limit on the number of hours that an RPA crew is allowed to conduct operations on a weekly basis is needed to lower the burnout experienced by the crews. Additionally, the demand for RPA operations dictates the supply of RPA crews must increase. Third, in line with Hugh Gusterson's theory, the definition of diagnosis of PTSD must be examined for the possibility that it is too narrowly defined. The solution to the problems experienced by RPA crews does not appear to be a technological one. The solution most likely lies in policy changes and an increase in the number of RPA crews. If I was in charge of addressing the effect of RPA technology on RPA crews, the first thing I would do would be to limit an RPA crew's shift to 9 hours. In my career field, aircraft maintenance, technicians will not work more than 9 hours unless the commander has approved extended shifts. A similar policy governing RPA crews could lower the burnout rate. Also, altering RPA crew schedules so that each crew works for 5 days and has 2 days off could also lower the burnout rate. Second, I would increase the RPA crew recruiting and retention efforts to increase the number of RPA crews. Recently, the United States Air Force approved training enlisted members to fill RPA pilot positions, which were previously only filled by military officers. This is a step in the right direction, but it may also have the effect of further marginalizing the RPA crews as second-class citizens. The major complaint of RPA crews is the long hours and low number of personnel. My plan would address both of these issues satisfactorily. Given the high demand for RPA surveillance and strikes, this plan is really the only way to meet this high demand without continuing to alienate RPA crew members. The issue of PTSD among RPA crews must be addressed as well by exploring the current criteria for being diagnosed with PTSD and either adjusting those criteria or designating a new name for what RPA crews can experience while performing their duties. If you have any questions about the material covered in this presentation, please contact me by email at christopher.klubertanz@snhu.edu. Thank you.